Hello everybody, today we are going to talk about the exponential form of a complex number. So in order for me to explain to you how we derive the exponential form of a complex number, I need to derive the Maclaurin series so that you can see it from the roots, because if you understand the roots you'll never forget. Okay, now I want to start off by deriving the Maclaurin series. Now if you have a function of x given by a0 plus a1 x plus a2 x squared plus a3 x cubed plus a4 x power 4 plus a5 x power 5 and so on. This is a function of x given by this, an arbitrary function of x given by this. Okay, and a0, a1, a2, a3, a4, a5 and so on, those are just constants. Now in order to derive the Maclaurin series, we need to find these constants, and to find these constants we need to let x equal to 0. Okay, and then replace. So replacing 0 for x, we'll have f of 0 being equal to a0. Okay, so we have our first constant a0 equaling to f of 0. Okay, if you replace 0 in these other places it will just be 0, so we remain with a0 equaling f of 0. Okay, now we need to differentiate this. So we'll have f prime of x. So if you differentiate a of 0, it will be 0 because it's just a constant. Differentiate that, a1 of x, it will be a1. Okay, plus 2a2 x. If you differentiate this, and the next one will be 3a x squared. If you differentiate this one, okay, now we differentiate this one, 4a cubed. Differentiate this one, plus 5a power 4. Okay, now letting x equal to 0, we'll have f prime of 0 being equal to a1. Okay, if you replace 0 in this other, you'll get 0. You remain with a1. Let's carry on. Now we differentiate this equation, so we'll have f prime of x being equal to, differentiate a1, you get 0, differentiate this, you'll get 2a2, plus differentiate this one, you'll get 3a3. I could have just written 6, but I've written it like this intentionally, and you'll see why in a while. Okay, now differentiate this the same way. I'll write it like that, and you'll see why I'm writing it like that in a while. Okay, good. And we differentiate this, plus 5, 4, 5x power 3. Okay, now we let x equal to 0. If you let x equal to 0, you get f you remain with 2, and meaning that a2 is equal to, make a2 the subject, f over 2. Now we differentiate this equation. Okay, so it will be f prime 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 of x being equal to, if you differentiate this you get 0, differentiate this you get 3, 2, a 3, plus differentiate this you get 4, 3, 2, a 4 x plus 5, 4, 3, a 5 x squared. Okay, now we let x equal 0 so that we can find the constant. If you let x equal 0, this will mean that f prime 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 of x will be equal to 3, 2, 1, a3, which will leave us with, making a3 the subject, a3 is equal to f prime 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 of x. So this should be 0, this should be a 0, because you're replacing 0 with 0. It's a 0, f prime prime of 0 over, if you've noticed, this is nothing but 3 factorial. So instead of writing it like this, we'll just write 3 factorial. Okay, let's carry on. Now let's differentiate this equation. We'll have f of x. If you differentiate this, you'll get 0. Now differentiate this, you'll get 4, 3, 2, 1, a 4. Okay, plus 5, 4, 3, 2, a 5 x power 1. Okay, now we let x equal 0. Let x equal to 0, and if you let x equal to 0, we remain with will be 4, 3, 2, 1, a 4. If you put x here, all of this will be 0. So finally, a4 will be equal to of 0 over 4 factorial. 4 times 3 times 2 times 1 is nothing but 4 factorial. Okay, so let's carry on. Let's differentiate this. F of x equal to, if you differentiate this, since it's a constant, it will be 0. Now differentiate this, you get 5, 4, 3, 2, 1, A5. Okay. Now making F5 the subject, we get that F0 over 5 factorial. Okay. Now that we have our constants A5, A4, A3, A2, A1, and A0, all we need to do now is replace them in our original equation. Okay. Replace the constants in our original equation. So f of x is equal to a0 is nothing but f of 0. Instead of writing a0, we'll write, okay, plus a1 x. Instead of writing a1, we'll write f prime 0. Okay, f prime 0 x plus a2 x squared. Instead of writing a2, we'll write f prime prime over 2. Okay, well, f prime prime of 0 over 2 factorial, and we have x squared, a3 x cubed. Instead of writing a3, we'll write f prime prime of 0 over 3 factorial. Okay, plus f prime 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 0 over 3 factorial x cubed. Let's carry on. A4 x power 4. A4 we have already here, so we'll write that instead of A4. 0 over x power 4. Now F5 x power 5. Instead of writing F5, we'll write this. Okay, plus F0 over 5 factorial x power 5, and so on. And with that, good people, we have just derived the Maclaurin series. This is what is known as the Maclaurins. And we are going to use it to derive the exponential form of a complex number. Okay, so thank you for staying with me. This is Understanding Math.